Mr. Beak's math class. Mr. Beak's math class. Yeah! Woo!
All right, how's everybody doing? It's me, Mr. Beak. Today we're going to talk about 2.3 multiplying and dividing inequalities. In case you can't remember what inequalities are, they're the less than or greater than signs, also the less than or equal to, greater than or equal to signs. Anytime you see one of those, know it's called an inequality because it's not equal, okay? Hopefully by the end of today, you'll be able to say, I can solve those pretty good. Multiplying and dividing is our new thing. And then just know that we're covering some math standards in this lesson. So, a little bit of self-reflection is what I like to do, a learning scale. Rate yourself on a 1 to 4 based on your understanding. The ultimate goal is to be at a 3 or 4, which means, hey, you can do these problems pretty darn good. You're not making any errors, besides maybe like an occasional one here or there, right? A 1 or 2 would mean, hey, you're making mistakes on like every other one, you're not getting right and stuff like that. So that just means, hey, we need to practice it a little bit more to get better. So today we're going to look at something. I got a big old chart here, and it's kind of got a lot of stuff. So just set your eyes right there. 1 is less than 4, and we're going to just work left to right. Is that a true or a false statement? 1 is less than 4. Well, that's a true statement. Okay. So then what we're going to do is we're going to do an action. We're going to do something. In this case, we're going to add 3 to both sides. So for example, if I add 3 to this side, I would be at 1 plus 3, which would be 4. And if I added 3 to this side, I would be at 7, right? And then the inequality was still that. Okay, so we ask ourselves, hey, is 4 less than 7? And that is true. So, started out true, ended true. Hip, hip, hooray. Okay? Let's do the next one. Also working left to right. Is negative 4 less than 6? That's true. If I subtract 3 from both sides, I'm going to be at negative 7 is less than 3. Is that still true? Yes, it is. Let's look at this next one. Negative 1 is less than 5. Hey, that's a true statement. If we multiply both sides by 2, we're going to be at a negative 2 is less than 10. Is that true? Yep. All right, I'm going to do this next one in blue. Negative 3 is less than 3. Guess what? That's true. But now what we're going to do is we're going to multiply both sides by a negative 2. That's going to give me a positive 6 is less than negative 6. Is that a true statement? And quickly, hopefully, you can see that's a false statement. 6 is not less than negative 6. All right? Back to red for this next one. Negative 2 is less than 10? Yep. If I divide both sides by 2, I'm going to be a negative 1 is less than 5. That's still true. Awesome. And last but not least, 2 is less than 8. That's a true statement. But if I divide both sides by negative 2 in this case, I'm going to be left with a negative 1 is less than negative 4. And if you stop and ask yourself, hey, that's not a true statement. That's a false statement. Okay? So, taking a look at these two things in blue, why did those become false? This is one of the big takeaways for the lesson today, and one of the things that you're going to have to remember. Why did those become false? Well, because if you look at what we did, we multiplied them by a negative number or divided them by a negative number. Okay? So, let me write this down real quick. When you multiply, I'll just abbreviate, or divide by a negative number, what happens? Well, our statements are false, right? They're not true. So how can we make these things true? Well, if we were to simply just flip the signs the other way, those would now become true. Understand that's a little kind of messy and sloppy over. But anyways, when you multiply or divide by a negative number, you need to flip the sign, flip the inequality. Okay? If you can remember that, you are well on your way to mastering this section. So let's just take a look at a couple problems. Let me fast forward there. I'm even going to fast forward this one. 2.3, solving inequalities with multiplying and dividing. Hey, look at this. That looks kind of familiar. Main idea. It says when you multiply or divide both sides by a negative number, flip the signs. Somebody just told me that. Oh, it was me. All right. A little bit of cheese for you. All right. So let's take a look at a couple examples. I'm going to just bounce around and kind of get through this fast. But if you have an inequality, we want to get x all by itself. And so what do? Well, hey, this is a multiply. This is 6 times x. So the opposite, the inverse operation is to divide by 6. And if we do that to both sides, we're going to end up with a negative 9 over here. But did I divide by a negative? Nope. So nothing out of the ordinary changes. It's still just that. Okay? I'll go back and graph those later. But I just want to get this idea in your head. All right? So if I did this, hey, we want to get w all by itself. So what do we have to do in this case? We have to divide by a negative 2 to both sides. That gets me negative 10. Did I flip the signs on this one? Yes. It was facing that way. It's going to face this way now. Why? Because we divided, in this case, by a negative number. So if it's a positive number that we divided by in this case, it stayed the same. If it was a negative number, right, we flipped it the other way. Okay? Let's just jump down to number 2 here. Oh, they try to trick you. They throw the x on the other side. We're too smart for that. We just know, hey, it's going to be on that side, right? And so how do I get rid of the 9 times x? I divide it by 9. And therefore, 9 times 9 is 81. So 81 divided by 9, also that 9. Do I flip the sign? Nope. That's still a positive number. That was a positive 9 that I divided by. So the sign opens up that way. Okay? How about number 1 here? I want w all by itself. So what I have to do, I have to divide by that negative 3. I have to get that out of the way, right? That's going to become negative 4. But on this one, if you take a look, oh, hey, I divided by that negative number to both sides. So the sign was opening that way. Now it's going to open this way. Okay? So it doesn't matter if your final result is negative or positive. When you multiply or divide by a negative number, that's when you flip the signs around. Okay? Now, a real quick reminder of graphing this. I'll just graph these bottom two since I have those up here. The important thing is we want to put the one number just right in the middle. That's the important number. We want to do one less, which when we're dealing with negatives is kind of a smaller number, but it's less negative, right? And then if we have the open or close, or excuse me, the less than greater than, it's going to be an open circle. If we have the less than or equal to, greater than or equal to, it's going to be a closed circle. Okay, so this one right here is going to be an open circle, and it says negative 4 is bigger than w. That, another way of saying that is w is less than negative 4. And if I graphed it this way, same answer, but if we wrote it that way, it would be easy to see, hey, I got to go less than 4. It's that way. Okay? And this graph over here, this one, hey, 9's the important number. We got one more, which is 10. One less than is 8. This one has an or equal to, so that means it's a filled in dot, closed dot. And it says 9 is bigger than x, so that means x is less than 9. Okay? Hopefully those make a little bit of sense. Let's do a few more. Those last ones, before I forget, those ones are all divided, right? Divided by this, divided by that. This one would be divided by that. These next ones, don't forget. Hey, these are already divided by us, so the opposite of divide is multiply. So this is a divided by 8. I'm going to times by 8. Get negative 40. I times by a positive 8. That means this sign's going to stay the same, just because I'm not going to flip. Okay? Letter B here, if I want to get y all by itself, How do I get rid of the divided by 3? I'm going to times it by 3. And you might be shouting at me right now, Mr. Beak, we still have a negative there, right? Exactly. If I want to do it in one step, I'm not going to times just by 3. I'm going to times by negative 3 because that's going to wipe out that negative there. So when I do that, it becomes negative 30. But what is our new rule? When we multiply or divide by a negative number, that sign flips around the other way. Okay? Let's go ahead and skip down to, let's do number 2 here. Here's my thing. I want W all by itself. I see it divided by 2. One simple, easy step. I'm going to times by 2, and I'm going to get negative 8 over there. Now, do I flip the sign? People might be saying yes. Why would they say yes? Well, I end up with a negative number. That's true. But did I multiply or divide by a negative number? No. We just divided, or times by this case, by a positive number. So it still is going to face that same way. Okay? Now, real quick graphing on this bottom one, just as a refresher. I should have graphed those other ones, but I wanted to kind of just show a bunch of problems. We always put the important one right in the center. We do one more, one higher, and one lower, right? We ask ourselves, is it an open or is it a closed dot? For this one, down here in number 2, it is a closed dot because it has that or equal to. And it says W is bigger than negative 8. That means those ones, bigger to the right. Okay? All right, let's just do this one last example here, number 3. Maybe cover that bottom one up so we just see the problem. All right, there we go. Hopefully you guys can see that. Example 3, modeling. You got a summer job, you work $9, you get $9.50 an hour. Not bad, even though now you get $15 an hour. I used to get $5.15 when I worked at Culver's in 8th grade. It was pretty awesome though. Could buy a lot with $5. Anyways, you're buying a digital camera that costs $247. Let's write and solve an inequality. Okay? Well, I know I'm going to have to use the $9.50. I know I'm going to have to do the $247. Let's figure out the middle pieces. There's got to be an X somewhere. The X is going to be located with the $9.50 because it says per hour. So I'm going to just say an X. Could say an H for hours, but I chose not to. All right? $9.50 per hour. And I want a digital camera that costs $247. Okay? I could say, hey, I want $2.47 or $247 exactly. That would be an equation, and that would be the answer. But what happens if we need to buy like a camera case or, you know, a memory card or something like that? Well, we might need more than $247, right? But we have to have at least $247. So if I need at least 247, I need greater than or equal to 247. That is my answer, ladies and gentlemen, for letter A. Okay? I haven't solved it yet, but if I had $250, right? That would be enough to buy that $247 camera, and I'd have a little bit extra to buy, you know, whatever I wanted. Okay? So how to solve this one? Well, it's just like we just did. This is a times. So $9.50 times X. I'm going to just divide by 950 to both sides. Wipes it out, and I'm going to get X. Do I flip the sign? Nope. And then you get some number there. I don't know what it is, but we'll call that good. Okay? So I'll work through these kind of fast, but hopefully your understanding is there. And so, you know, you can rate yourself at a 3 or a 4 that you can correctly apply these concepts, and then you get questions right. If you're at a 1 or a 2 right now, well, I just challenge you to, you know, practice some more problems, get some help if you need it. But I think that is all for today. Take care.
Mr. Beak's math class. Mr. math class.